Ever catch yourself thinking out loud to solve a problem? Like actually talking it through helps somehow. Turns out, AI might be onto something there.
It's wild, right? This whole chain of thought prompting thing, or COAT for short, it's like giving large language models a serious upgrade in the thinking department.
We're talking about those AI systems that can practically write you a term paper, but now we're teaching them to, what, think things through better.
Exactly. Imagine asking an LLM to solve some crazy complex problem all at once, like asking someone to multiply a huge string of numbers in their head. Good luck with that.
Yeah, my brain would be fried. I'd need a pen and paper, break it down step by step.
And that's the beauty of code prompting. It's like we're giving LLMs that pen and paper, that ability to tackle problems step by step, just like a human would.
So instead of aiming for the answer in one shot, they're breaking it down. But hold on, doesn't that mean we need to train them on, like, tons of examples to show them how to break things down?
You think so, right? But that's what's so fascinating. It's shockingly simple. Researchers found that just prompting the LLM with something like, let's think step by step, that alone led to huge improvements.
No way. Just a little nudge in the right direction unlocks a whole new level. Seems almost too easy.
It does, doesn't it? And get this, it even works when they fed the LLM's examples with, get this, incorrect reasoning. Even with those flawed examples, the model still performed better than those without any QAT prompting. Wild.
So it's not even about the accuracy of each little step, but more about the process itself, like going through those mental motions. That's what changes how the AI processes stuff.
That seems to be the key takeaway here. Researchers are suggesting it helps LLMs overcome a fundamental limitation in how they operate. See, without Cargly, they process everything in parallel. That's great for some things, but falls apart with those problems that need a specific sequence of steps.
Like trying to bake a cake by chucking all the ingredients in at once. Yeah, not going to end well.
The perfect analogy. And that brings us to the concept of inherently serial problems. And that's where this research gets really interesting.
Inherently serial problems sounds kind of intimidating, like we're diving into some serious computer science stuff.
Nah, it's not as scary as it sounds. Think of it like this. Some problems are like, when you're making a big salad. You can chop all the veggies at the same time. Doesn't matter what order you do it in.
Why silly? As long as it all ends up in the bowl, you're good to go.
Exactly. Those are problems that are, like, easily parallelized. You can solve them by doing a bunch of things at once. But other problems, these inherently serial ones, they're more like, remember that cake analogy?
Oh, yeah, I got to follow the recipe step by step.
Exactly. Trying to do everything at once, that'd be a recipe for disaster.
So those are the problems that trip up the traditional LLMs, huh? Trying to make a cake by throwing everything in at once.
Spot on. And what this research suggests is that COAT prompting, it's like giving them that recipe, allowing them to actually tackle these more complex sequential problems, which is something they really struggled with before.
Did they give any, like, real-world examples of these serial problems that COAT helps with? I'm still kind of stuck on the baking thing.
They do. One that really jumped out at me was how COAT impacted an LLM's ability to solve this thing called the permutation composition problem.
Permutations, ooh, that rings a bell from, like, way back in math class. Can't say I remember exactly what it is, though.
Don't worry about it. A permutation is just like a specific way to arrange things. Like, imagine you've got a deck of cards. Every time you shuffle it, you're creating a new permutation of those cards.
Okay, so far so good. But what does it mean to compose permutations? Is that like shuffling the deck a bunch of times in a row?
You got it.
Yeah.
And it turns out figuring out what the final order of the cards is after you do a bunch of shuffles, especially with a big deck, it's actually a really complex problem for a computer to solve. It can't just cheat and take shortcuts. It has to go through each shuffle one by one.
And that's where our friend COAT swoops in to save the day, right? It's like it lets the LLM keep track of each shuffle individually instead of trying to jump to the final order all in one go.
Exactly. The researchers found that without COAT, LLMs were, well, pretty terrible at these types of problems. But with COAT, they were able to actually predict the final order correctly, even after multiple shuffles.
It's like they finally learned how to play cards. That's pretty neat. So that's one example. Did they look at any other kinds of these serial problems?
They did. Another one that stood out was what they called the circuit value problem.
Circuits. Okay, now we're really getting technical, like electrical circuit.
Well, yes and no. Think of a circuit more like a flow chart in this case. You've got a starting point and then a series of decisions or gates that lead to different outcomes.
Kind of like those choose-your-own-adventure books. Each choice takes you down a different path.
Perfect analogy. The circuit value problem, it's all about figuring out the final outcome or output of the circuit based on whatever inputs you give it and how those gates are connected.
So it's not actually about electricity then, it's more about logic and following a specific path through a series of decisions.
Exactly. And just like with the card shuffling example, this is a task that's really tough to parallelize. You have to follow each step in the circuit to get the right answer.
Okay, I think I'm getting it, and I bet this is another area where Code T made a big difference.
You bet. LLMs without Code T really, and I mean really, struggled with these circuit problems. But with Code T, their performance shot way up. It was dramatic.
So there's definitely a pattern here. Code T is like giving these LLMs the ability to think things through in a more, I don't know, organized, human-like way.
Precisely. And that opens up a whole world of possibilities because these serial problems, they aren't just some abstract math puzzles. They actually have real-world implications in areas like them.
Okay, so we've covered baking cakes, shuffling cards, even navigating those flowcharts. I'm starting to get a feel for how this serial thinking thing is not just some abstract idea, it's got real-world potential.
Absolutely. And it gets really interesting when you start thinking about the implications of Code T for things like, say, legal arguments. Imagine an LLM that can break down those complex legal arguments step by step, finding flaws, inconsistencies, you name it.
Whoa, that's wild. Or what about scientists using LLMs to, like, design those super intricate experiments, ones where each step builds on the last, you know?
Exactly. It's like we're not just teaching AI to process information, but to actually reason, to strategize, kind of like we do. And it goes even further than that even.
Yeah.
Think about LLMs that could help us understand, like, literature in a whole new light.
You mean like tracing a character's development over a whole novel, or how those subtle themes all weave together?
Exactly. We're giving them the tools to appreciate those nuances that art in ways we never thought possible. It's pretty mind-blowing when you think about it.
It really is. Though it does make you wonder, is there a limit? I mean, Qt is powerful, but there's got to be a ceiling somewhere, right?
That's the million-dollar question, isn't it? We're still figuring it all out, to be honest. This research, it's really just scratching the surface.
So what are like the big mysteries? Where do we go from here?
One of the big ones that has researchers scratching their heads is understanding why certain prompts work better than others. Like, they found that if you just have an LLM spit out random words, even if it's the same number of words as a meaningful explanation, it doesn't have the same effect.
Huh. So it's not just about thinking more, it's about thinking right.
Exactly. There's something about those meaningful steps, those logical connections, that seems to be crucial. And figuring out how to, like, optimize that, how to craft those super effective prompts, well, that's a whole area ripe for exploration.
It's like we've stumbled upon a new language for AI to think in, and now we need to master it ourselves.
That's a great way to put it. And as we go deeper down this rabbit hole, it's important to remember, this isn't just about building a better AI. It's about understanding intelligence itself.
You're saying that by studying how AI learns, we might actually learn something about how we learn. Whoa.
Precisely. By watching how these models benefit from this structured step-by-step thinking, we're getting these little glimpses into, like, the core of how our own brains might work. It's like holding up a mirror to our own minds.
I've got to say, this whole conversation has been pretty mind-blowing. We started with these simple prompts, and now we're talking about AI reaching these crazy new levels of understanding and maybe even revolutionizing how we understand ourselves in the process.
And that's just it, isn't it? It's a field that never sits still, always pushing the boundaries, always making us rethink what we thought was possible.
And as we've seen today, even small changes like adding that think step-by-step idea can lead to some pretty huge leaps forward.
For sure. Who knows what other breakthroughs are just around the corner?
That's what makes it so exciting. For those of you listening who want to keep those mental gears turning, check out the research paper we talked about today. You can find a link to it in the show notes.
It's a fascinating read. Might just spark a chain of thought or two.
And until next time, keep exploring, keep those questions coming, and never lose that curiosity. Thanks for joining us on this deep dive.